Okay, welcome to another data recovery case. This is case 721397. Our customer, his name is Austin. He sent this drive to us all the way from New Jersey. And another customer that asked us to see if we could record a recovery for him, record their recovery, and document the process. So that's what we're going to do. We do it every now and then, and we hadn't done one in a while, and actually we haven't really had time to do them, but this one here certainly is worth it. The customer had stated that they actually had their laptop on top of their car and didn't realize it, and once they got in, started talking to whoever they were with, they drove off, and next thing you know, they're driving down the road, and a few moments later, the laptop slides off the roof of the car and tumbles down onto the pavement. So they said that they'd powered the drive up, or powered the laptop up again just to see if it would work. It didn't power up at all. Luckily for them, it didn't. Sometimes impacts like this on laptop drives can be pretty bad. The heads typically park in this area, and the platters are just the small discs that are inside there. And what will happen is sometimes whenever a drive is dropped or bumped or knocked over, the heads actually come and park, and they will land on the platter surface and bond to the platter. There are some videos out there that show people basically just turning the platter and scraping the heads off of the platter surface. That's all well and good if you have data that you don't really care about recovering or not. That's not the case here. This customer stated that they have some extensive backups on this particular drive that they need to have recovered. It's got pictures and documents and company files and things like that that hadn't been backed up anywhere else. This has a directory, I guess, that was supposed to be scheduled as their backup, and they just hadn't gotten around to doing it, I guess. So anyway, the point is, it really depends on the value of your data. If you have data that, like I said, is not all that important, then by all means try whatever you find that might be relevant to the type of hard drive failure that you've suffered. But if you have data that you absolutely need to have recovered, your best course of action is just to not mess with it at all. So that's where we are with this one. They did a great job of packaging it too. This is a small laptop drive, but you can see how big of a box they put it in. So plenty of packaging there. The thing must have had about 70 layers of bubble wrap on it, it seemed like. So the drive may have taken a tumble before, but it definitely was kept safe and sound during the shipping process. So we will go ahead and take a look at this drive and crack it open and see what the problem may be. I'm not for sure if they opened it or not. There's a little bit of a tear down here in this label area. They said that they didn't open it, but that's just, and it could be that maybe they thought about it. I don't know. I'll need to talk to them some more about it and see if there's any more details they can shed. But once we start looking at it inside, we'll be able to tell if anything was done before we received it. So anyway, we'll go ahead and get started. We'll move this out into our laminar flow hood, which creates a Class 100 clean room type environment for the areas that we actually work on these drives, and it's pretty common piece of equipment that's used by most data recovery companies. So it just keeps the dust particulates and things like that down to an absolute minimum. So we'll go ahead and open the drive under that and follow up with you when we get to that part.
Okay, for this part of the data recovery process, we're going to go through and take a look at the platters and the heads and see what condition they're in. I'm actually narrating over this right now because under our flow hood it's almost impossible to talk over the noise of the fans in real time as we're actually working on it. And this is just going to be kind of a brief overview highlighting a little bit of the actual physical repair of the drive itself, not really even getting into too much of that. Our real focus is going to be on actually getting the data off of the drive during the later phase of the recovery. So right now we are going to go through and just do an inspection. This is kind of the initial evaluation on the drive. customer's already said that they want the data recovered regardless, so we're not going to have to pause and wait for them to respond like we've done in some of our other videos. This is data they absolutely have to have, and so we're going to go ahead and move forward with whatever we need to do once we take a look at this. Most cases, when a drive's been dropped, we'll see either the heads are severely damaged or the heads are seized to the platter surface. Either case, it's usually pretty detrimental to the hard drive itself. And you can see here pretty obviously that the heads have come apart and they have fallen onto the platter surface, well into the platter, and are stuck there. And I went ahead and took a picture of that so you could see a close-up view of what I'm seeing as I have the drive open. And the orange piece up there at the upper part of the screen is actually the ramp that the head should be parked on. When the drive was dropped, when the laptop was dropped, the heads came apart and they scraped along the platter surface till they finally seized where they are right now. Now there are people that will suggest you can just rotate the platter and slide the heads off. And yes, you can do that, but if it's data that you absolutely have to have, do not do anything with the drive. There's a way that you can take the heads off, that a tool that we use that prevents any damage from occurring. So it really comes down to the value of the data. In this case here, the value to the customer was priceless as far as they were concerned. They had to have the data back. So, there's no reason to go through and follow some, advice as far as just pulling the, rotating the platters and grinding the head across them, because that's what you do. The heads will essentially just grind right across the platter and you risk damaging them even further. So I just went ahead and took the controller board off because we know we're going to be needing to make some repairs. Now I'm going to bring in the parts drive here. Now we need to do an inspection of the parts drive first, because even if they're the same model, same firmware revision, everything, there can be subtle differences between the head stack assemblies. I know in the customer's drive that there's 4 heads that are actually active. The thing is you can actually have 2 drives that are exact same capacity, same model, everything matches up on paper, but you may have one drive using a different head mapping. Sometimes they'll actually have 3 heads in there, whereas the other drive might have 4. Sometimes if they have 3 heads active, you may have different ones that are deactivated. So there's just little things that we just want to make sure of before we do anything else. So they all match up pretty well, so we're going to go through now and start the process of actually trying to get the customer's drive fixed. And right now we're just going through and taking the screws out that hold the magnet in place. And we need to remove the magnet, and we also need to remove the 2 screws that hold the ribbon cable that interfaces to the controller board from the head stack assembly. And that's what we're working on next. And after that's done, we actually have a tool that we use, and if you do some research, you may find them online. They're very expensive, that allow you to remove the heads from a seized platter. The tool that we use, though, is a little bit different, and it's one that we create ourselves. And right there, we're just removing the magnet, and we are getting ready to go through and start removing the head, or at least preparing to remove the head. To use the tool that we have, we actually have to remove the parking ramp in order to be able to angle it onto the platters and get underneath the head when it's seized on the platter surface. So once we have that done and we remove the head, then the drive looks like this. So right now it's ready to receive the replacement heads. And the next phase of the process would be going through and disassembling the parts drive in the same way. And for data recovery purposes, everything needs to match as much as possible for the head assembly and everything else for the components to work together and be usable. And the next phase will be us going through and testing the drive and seeing if it works.
Okay, moving along with case 721397, this 640 gig Toshiba hard drive that was sent in by Austin. Just a little review. The drive was dropped, so we've got the repairs made to where the drive will function again now. And we have it connected to our hardware imager. And this is an imager that's produced by Deepspar. And you can look them up on the internet, find more information about them. It's a pretty high-end imaging solution for hard drives and for data recovery purposes. And when we say imaging, we're really cloning the drive, not necessarily making an image file like a lot of software out there says that it does. We're basically just taking each sector of this drive and cloning it over to this destination drive. So the first thing we do is power the drive up and then configure the imaging software to handle this drive and its condition that it's in, whatever that is. So first thing we'll do now is power it up to see if the drive is even going to work properly after the repair. Up here at the top of the screen it says busy. That means it's calibrating, and it came to a ready state, so it did calibrate, which is good. I'll refresh the screen. Hopefully our drive shows up, and there it is. That's our customer's hard drive there. And once it's ready, I did hear make a few ticks there, so I'm not sure if it's having a little bit of a problem. Okay, nothing come up there. So what we'll do is make a couple changes here into some of the settings. And what this imager does, you may have seen some of our other videos, is it makes multiple passes over the hard drive during the data recovery process, during this phase of the data recovery process, I need to say. What we can do is we can actually change it, different settings in here. We can change the read timeout for each sector. So right now for this first pass, it's going to go through and just read anything and everything it can as quickly as it can. And if it has any type of issue reading a sector, it's going to skip a block. So right here we have the setting to where if it can't read a sector within 300 milliseconds, it's going to go ahead and skip the next 120 sectors, and that's what this check mark here is for. And that's just for the first pass that it makes. The secondary pass, it's actually going to go backwards, and then it's going to start cleaning up the sectors that it skipped on the first pass. And so right now if it'll have a 1 second timeout, and we're not going to skip these sectors here, that's why this is unchecked, but we are going to go through and instruct the drive to use internal read retries. So we're going to try to make it read those sectors that it skipped more and more fervently in order to be able to try to get as much of those unread sectors read again. On the third pass that we make, the timeout is quite a bit more. It's at 7 seconds. We aren't going to go through and ignore ECC errors on this particular drive. A lot of times Toshibas do not like that at all. But we don't necessarily need to make 10 attempts on it. So everything is set there. What we're going to do now is go through and generate a head map. The head map tells us which heads read in what areas of the platter. That way if we have a problem with a head reading, we can go through and deactivate that head. If we have a problem with a platter surface being scratched, we can deactivate that head so it doesn't necessarily focus on that platter at all. And then we just read the remaining good heads. So this is going to start. It's going to take a little bit of time. I'm going to pause the video, and once that's done, it will go through and have the head map done, and we can deactivate whatever heads we need to if we need to do that. You can see here head 0, head 1, head 2, head 3, and these are the sectors that it's reading. So we're going to pause that and come back when this is completed. Okay, now we have the head map generated. The next phase is going to be generating the bitmap. The bitmap is going to tell us the layout of the data on the hard drive itself. It's going to tell us what sectors are occupied by certain data. It's going to allow us to select certain data, certain directories to be imaged, and that's what we are going to do now. We've gone ahead and determined that the partitions are there, And so we see the NTFS partition. It tells us where it starts and then how big it is. The customer only needs one directory off of this drive. That's the most crucial directory that's on here. And so we're going to try to just image only those sectors at first. We don't want to go through and image the entire drive, because at that point you could be spending a lot of time imaging areas of the drive that aren't needed, for one thing, but also wasting whatever life these heads may have in them. So we're going to go through and focus on the directory that they absolutely have to have first, and then if everything goes well with that, we'll go back and image the remaining data. So we'll go ahead and hit that, and then we are going to select this directory. You can go through and you can have a specific directory, you can have specific files or file extensions. Right now they just need a directory, and it is backup. This is they gave us backup dash 16 dash May dash 17. Let me just reread that off the screen for their case information. Backup dash 16 dash May dash 17. Good to go there. We want to get all the files out of that directory, and we get all file extensions out of that. So now we'll go through and start imaging the partition table to get all of the files within there, and now it's starting to select them. Well, that is not good, because this says total size 0, fragment 0, 0 files. So either that directory is not there, or there's an issue with the partition table to where it doesn't show the directory properly, which I don't think that there'd be a reason for that happening. So now it becomes a concern that, well, maybe the data that they need is not even on this drive, but hopefully it's just something where maybe it was named wrong, or I'm just double checking what on the screen that I have pulled up on another system here that has their information on it, but I put it in exactly like that. So I think the next course of action maybe is to go through and put this drive onto our PC3000 machine. It'll allow us to actually have a user interface that will give us a better view of the layout of the data, and see if we can see this directory that they're needing on there. So I'm going to go through and we're going to cut over to that machine with this drive and see how that works for us, and I'll explain a little bit more about how that works in this next segment. So hang on. Okay, so now we have the drive connected to our PC3000 system. Just as a summary, PC3000 allows you to have a lot of access to different firmware areas of the drive. You can make a lot of changes. You can go through and have a lot of flexibility with getting the drives to function when they have firmware issues, and also some of the Western Digital drives where it's not easy to go through and just swap controller boards. This allows you to have the ability to reprogram the code from one board to another board, so that that board will actually be compatible with the patient drive. But these are some of the different brands that it supports. And for this 640 gig Toshiba drive, we're actually not going to be really doing too much within the PC3000 utilities. We're actually going to be using the data extractor portion of it, that tool, which is pretty powerful in itself, and it's a great add-on. It's one of those things where, it doesn't make sense to have PC3000 if you don't actually have the data extractor too, just because of what it allows you to do relatively easily. So we'll go ahead and power up the drive, and you have the indicator down here that's busy, and then these two indicators come on that it's ready, similar to what we had on our deepspar imager. And I just heard the drive make a little flunky sound, so we are going to go ahead and speed this process up. I definitely don't want to come this far on getting Austin's drive recovered, then have these heads fail on us again, which is another reason why it's important to go through and utilize some sort of hardware imager or utility like this. So we auto-detected the brand. We'll go ahead and auto-detect the
family as well. Oh, sorry. And it auto detects what family it is as well on here, as long as the drive itself is functioning normally. And it gives you a brief readout of some of the information that is pertinent to this drive. Up here you have the firmware revision, serial number, and all of the information you need for that particular drive. What we are going to do though right now is make hay while the sun is shining and get out of this and go right into our data extractor program. When you come up in here, you want to create a task, and I always name these based on the case number, so 721397. The source drive, our customer's drive, is connected to the PC3000 SATA 1 port. These will stay the same. We want to make a data copy. Now you'll remember too that we had the drive connected that I said we could clone to. I'm hoping we don't have to go through and clone the entire drive. I'm hoping we can find this directory that the customer needs, but if we need to use it, we're going to go ahead and select it now. And you want to be careful on these that you don't accidentally select the wrong drive. You can see that we have two 3 terabyte drives connected to this system, and we don't want to accidentally write anything to this one, so you want to make absolutely sure that we've connected the one with the right serial number to verify. Hit OK, and that should initialize our data extractor tool. Down here we have some of the tabs for the map. The map is actually just the layout of all the sectors on the drive. You can scroll through these, and right now they're all white because they haven't been read. But once they're read, they'll turn hopefully mostly green if everything's going right. But there's a little legend here as well that tells you, based on what color the sector was, what issue it may have had, or what function was run on it. Right now, we could go through and just hit execute, and we'd start cloning this drive to the next, but we are going to hopefully be able to explore this file system. We were able to generate a bitmap on the deepspar imager, so I don't see any reason why we shouldn't have that here. And this is essentially how this works. I'm going to show you. It's really nice. This is our connection. These are the drive, what's been detected as being connected under that SATA 1 connection. This is the partition that's connected under this disk that it sees, and we'll see if that's the user partition. It may be. Nope. This is actually just a probably a backup boot partition that was set up when the laptop was initially set up, or it may be an old partition. You can see here that these blocks had started to change green. That's the only amount of reading it does to be able to tree up these folders. So you can see we're getting a folder structure without having to go through and read the entire drive. We'll do this next one. See what this looks like. You can see every time I click, these change. It'll read some of the sectors that are pertaining to this particular partition. And okay, here we go. This is what the customer's looking for, and actually it's pretty close to what we had typed in. Let me look over here on our other machine. No, I see the problem. The customer had given us the information backup-16-May-17, but it's actually backup_16-May-17. So that is the problem right there. And yep, there's our customer profile for Austin, and we are going to go ahead and mark that. And at this point, I'm only going to focus on trying to get these. And once you hit this is essentially this play button, this looking thing is actually what executes the function of what it is you want to do. Right now, I want to just save this data. Save current. I'm not cloning it. I'm actually going to be pulling it directly off the drive. We're going to try to get this as fast as we can. Save current, save marked in current folder. Yes. And actually, we're going to save all marked. I just have a habit of doing that, and I don't want to change that. Go here, and I'm going to go ahead and put it in the folder that we have already created for this. So this is the folder that's going to go into 721397. That's our case. And hit OK. And hit yes. Now, if all goes well, it's going to go through and copy that data that is contained within that directory, which is the directory that the customer absolutely has to have. And as you can see, these little sectors sporadically are turning green. The data is somewhat fragmented across here, which is not a bad thing. If you were to go through and old school defrag the drive like they used to do 15 years ago or whatever, it would probably clean up this a little bit more because these are kind of sporadic and spread out. But you can see it going through though, and everything that it reads, every sector that it reads successfully turns green, and every sector that it is reading is directly related to this backup directory that our customer needs. So we are going to go ahead and let this run for a while. I'm not sure how much data is going to be on here, but we will go ahead and let this execute until it completes, and then go back and just make sure that the data looks good. If everything looks good there, I'll verify with the customer whether or not there's anything else that they need off of here. It sounded like they were pretty adamant that this was really all they wanted or cared about, but I always like to make sure, and sometimes we'll still go through and just copy everything else off just to make sure that we haven't missed anything. But so this looks really good. Much better than trying to let it image an entire 640 gig drive when it may not be necessary at all to do that. And we don't want to necessarily image the entire partition because we don't need things like the program files directory a lot of times, program data, or the Windows operating system directory. So this right here, whatever life we have out of the drive, we are making the most of it by running this process like this, especially since we didn't know for sure. We had incorrect information about what directory was needed. If we had input the directory initially the way it was, then it wouldn't have been a problem. We would be able to go through and at that point just generated the bitmap, selected that directory, and been done. So anyway, we're going to go ahead and let this complete, and then once it's done, we will follow up and see how everything looks. So stay tuned. Okay, and we have the data recovered for Austin on case number 721397, the 640 gigabyte Toshiba drive that we've been working with. That backup directory that he was needing has been safely transferred, and we actually went through and just copied that directory over using PC3000, as you just saw. And now what we'll probably do is go ahead and put this drive on the imager and just make sure that we get a full clone of the drive, just to make sure nothing's missed. But we wanted to make sure we focused on getting this directory here, the backup directory, which has the user profile, the documents, desktop files, everything else in it that they need. So that is a good recovery, and let you see a little bit of a different approach that we have to take sometimes with these. If you have any questions at all, feel free to visit our website at acsdata.com. You can also give us a call at 1-800-717-8974, and we will be happy to help you with any questions you might have. Thanks for watching, and have a great day.